go. Today we're going to be talking about factoring, factoring out a common factor. So a common factor. And then, of course, we're going to be talking about factoring out quadratic equations, but first by pulling out that common factor, which makes the problem so much easier. All right, so let's go ahead and jump right into it here. So, extend the page down. Let's talk about what factoring is right from the get-go. So factoring is basically breaking down a problem. So if I have 40, the number 40, and I break it down and I factor it, there are numbers or factors that go into 40, such as 4 and 10, or 1 and 40, or 2 and 20, or, let's see, 4 and 10, got that one, 5 and 8. These are all factors, okay, all factors of 40. Now, when thinking about a common factor, so this is factors of just one number. If I'm talking about a common factor, I'm going to talk about a factor between two numbers that's common. Common meaning in the same, both 20 and 40 contain it. So common factor. Let's look at factors of 40 and 20. Well, 2 and 10, 4 and 10. So a common factor in this case would be 10. So a common factor would be 10. So that's what factoring is, and that's what common factor is. This should, if you know this, then we can build on it. But this, you have to know and understand what factors are before I can talk about anything else, really. All right, so let's talk about distribution first before I get right to the heart of the lecture here. If I have a 3, parentheses, x squared plus x, close parentheses, and I distribute that 3 to both, and I multiply that through, then I have 3x squared plus 3x. All right, I can even ramp it up. I can go 3x squared, open parentheses, 4x plus 6x. And I'll make this one a squared, just for kicks, close parentheses. So I have 3x squared times 4x squared plus 6x. And when I distribute that 3x squared through, I get 3 times 3 is 12, x to the 4th, plus 18, x to the 3rd. So I'm just taking and multiplying that through, distributing. So these are all common things that distributing and factoring that you need to know before we talk about pulling out common factors, polynomials, and of course, factoring quadratics. All right, so here we go. Let's talk about common factors. So I can have, just like with the 20 and 40, I can pull out a 10 from both of them. All right? I'm going to ramp this up a little bit and add variables in here as well. So let's look at a polynomial 2x squared plus 4x. All right? Well, let's not jump that high yet. Let's go just like this, 2x squared plus 4. Now let's look at the common factors between 2 and 4. 2 is a common factor because 2 goes into 2 and 2 goes into 4. So I'm going to pull a 2 out here. Notice that it's 2x squared plus 4. All right, that is a polynomial. Well, it's a quadratic. So we're going to pull a 2 out. And when you think of pulling, when I say pull a 2 out, is what I'm really saying is reverse distribute. So we're doing distribution backwards. Okay, we're undoing that distributing. I'm going to pull a 2 out. I'm going to open parentheses just like it looks like with distributing. And then what's left in this whole expression, if I pulled out a 2, I have x squared plus 2. Now, if you really want to think about reverse distributing with this equation, so I pulled out my common factor, if you want to think about it, you can think about redistributing this 2 through, and you're going to get this original equation. Because 2, parentheses, x squared plus 2, close parentheses. If I go 2 times x squared, well, I get my original statement, 2x squared. And I distribute that 2 to the 2, then I get 2 times 2 is 4. Okay, let's see some more examples here. So, let's go 3, now let's go 6, x squared plus 9. Make things a little tougher, not much. But all right, so we're going to reverse distribute. We're going to factor a common factor out. So the directions here would say factor out a common factor. And a common factor, in this case, look at the numbers first, 6 and 9, and I can pull out a 3. So I'm going to go ahead and pull a 3 out. I'm going to factor out a common factor. I'm going to pull out a common factor. That makes more sense. I'm going to pull out a 3 here. So I have 3, open parentheses, 3 times 2 is 6, x squared plus 3 times 3 is 9. Good. Oops. So now remember, always keep in the back of your mind is what we're doing here to get this, end result here. And this is your answer if we pulled out a common factor. We're just undoing the distribution here, pulling out a common factor. So there we go. If you wanted to check your work, you can always take this 3 here and distribute it to each of them. Okay? Distribute it to the 2x squared and plus 3 and call it good. Good. So let's ramp this up a little bit. So first, I've just been dealing with numbers here, but I can throw in variables as well. I've thrown in this x squared, but so what, right? So go ahead and make this a little tougher for you. Not much, but. All right, so let's look at 6x squared plus 9x. Now, this is exactly like the other problem, except I added that x with the 9. So first off, pull out a common factor with the numbers. Deal with the numbers first. So I can pull out a 3. So I'm going to pull out a 3 here. So I have 3, open parentheses, 2x squared plus 3x, close parentheses. Good. Now, if you look, now we're pulling out common factors. Well, look right here. These two expressions, 2x squared and 3x, which are expressions, okay, they're just kind of, it's a variable and a number, divided by a addition sign here. So these two expressions here have an x in common. Here is 1x and here is 2x. So I can pull a total of 1x out from each of them. Now remember, think about distributing. When you distribute something, you're distributing it to all of them. So when you undo it, you have to pull it from all of them. Okay? You can't just magically pull an x from one of these expressions here. You have to pull it from both. So I'm going to go ahead and pull, I'll do this in red, I'm going to go ahead and pull an x from each and bring that x out front. All right? So when I do that, it goes right with the 3x, open parentheses, and I have 2x. Now remember, I pulled an x out, so I have 1 less there. I had 2 x's, now I have 1, plus 3. And I don't have an x there now because I pulled it out. And remember, you have to pull it from both. Okay? You can't just magically pull it from one. Good. There we go. That's the end result. Now you can always double check your work by right here going to this equation I created of pulling out that common factor to the 3x and distributing that 3x to the 2x plus 3, and you always get the original statement back, the 6x squared plus 9x, because 3x times 2x, 3 times 2 is 6, x times x is x squared, so 6x squared. Yep, that's what that is. And then 3x times 3 is 9x. Yes. So you can always do that. You can always check your answer by putting that 3x back into the whole polynomial. Now let's ramp this up, because not only can I deal with things like x squared plus x, some number x squared, some number x, I can make this as long as I want. So let's really ramp this up, and let's go 4x to the 5th plus 4x to the 4th minus, let's go 8x to the 3rd, and let's go plus 12x squared. Basically, I'm going to stop because I ran out of room. But now, the only thing you do, you can do the same. We're just going to pull out a common factor. So the directions here is pull out a common factor. Okay. Now, you just go through and you look at the numbers. I'm going to look at the 4, the negative 8, and the 12. What's a common factor between all of those numbers? Now remember, when you reverse distribute, when you pull out a common factor, you have to pull it from all of these little expressions here. And the expressions, when I say expressions, I mean the whole thing here. I mean the 4x to the fifth is an expression, 4x to the fourth is an expression, 8x to the third is an expression, and 12x squared is an expression. And they're all divided, it's like separated, if you think of like a wall between them all. And there's that wall is the addition, subtraction, addition sign. So it's either addition or subtraction separating these little mini expressions. Okay? So when you pull out something, a common factor, you have to pull it from all of these expressions. So I'm going to go ahead and pull, let's see, a 4, 4, 8, and 12. I'm going to pull a 4 from all of them. So I'm going to pull a 4 from each one of these things. And this is exactly what you're doing. But all these lines, this is what I think about mentally when I'm doing this, when I'm pulling out that common factor. So I'm going to pull out this 4, and I'm kind of imagining this in my head, which may or may not be weird. But I'm going to pull out this 4, and then I'm going to open parentheses and think about reverse distribute. With this 4x to the fifth, if I pull out a 4, I only have x to the fifth left, and then plus with this one, I only have x to the fourth left, and then with this one, I have negative 2x to the third left, and then with this one, I have plus 3x squared left. Good. Close parentheses. Nice. So now, after you pull out the numbers, always go back and check to see if you can pull out any numbers. So I have an x to the fifth plus x to the fourth minus 2x to the third plus 3x squared. There are no common, we're dealing just with the numbers here. There are no common factors I can pull out. Good. Now after you're done there, let's look at the variables. And I just have x's here. You can have multiple variables, but we're just dealing with one variable here, x. So you go through, and then let's look at how many x's we have. Here we have 5, here we have 4, here we have 3, and here we have 2. So the lowest number of x's there are is 2. So we can pull a total of 2 x's from each little expression here. So I'm going to pull 2 x's from each of these. So I'm going to pull an x squared out from each of these. So when I pulled an x squared out, I have 4x squared. And then how many do I have left here? Well, I pulled 2 of them out, and I had 5. Now I have 3 of them. Plus, now I have x to the fourth, and I pulled 2 of them out, so I have x squared, minus, and then 2x. I pulled 2 of them out, now I have 1, and you don't really need to write the x to the 1 power. Okay? You can if you want, but no need really. Good. And then I have plus 3. I had an x squared right here. I pulled 2 of them out, so that's it. I don't have any x squareds left. Now, you can always redistribute that 4x squared, this, back into this huge polynomial here. You can always distribute that back in, and you can always get the original up here in green. You can always get that expression back out. So here we go. Just double check our work. X squared plus x to the third plus x squared minus 2x plus 3. I don't see any common factors that we can pull out of there, and I pulled out my 4x squared. So this right here is my final answer. Now this may not look like a final answer because it's still big, and most of you guys are used to getting like x equals 2. But this is done. I pulled out common factors, and that's it. Good.